Paper 1, 2025. Yeah, I just like the new outlook of this paper. I mean, the format, the way it is, and as much as I feel there could be also some challenges with combining the question paper together with the answer book. Nevertheless, let's dive into the paper with 11 questions. All right, question number 1, they're telling us that if you're given the f of x being x squared minus 3, then 3x minus 1, and then x plus 2, we need to solve for the function of x, okay? If the f of x, so if f of x is equated to 0, okay, we must solve for x if x is an integer. Now, we know that integers are basically positive and negative whole numbers. But looking at the brackets, we consider the only answers we're getting. Okay, before we even get into the integer part and stuff, let's try to solve this thing, okay? So we know that if we equate it to 0, this, we're going to have x squared minus 3 is equal to 0. X squared is a 3. And then find the square roots on both sides, meaning that we're going to have a plus or minus square root of 3. That's for the first bracket. With the second bracket, x is going to be a third. And then with the third bracket, x is going to be a 2. Now, if x is an integer, that's good as saying x plus 2 is going to be a 0, and then x becomes a negative 2. So we are saying that this negative 2 is the only answer that we have, because this can lie on a number line, and we know that integers can never be fractions, okay? Then 2, rational. We know that a rational number is basically a number that could be expressed as a fraction. So in this case, our x can be 1 over 3, or even x can be a negative 2. These are all rational numbers. And then x is a real number, then we can have all the 3, because all the 3 will be real numbers. So x is a third, x is negative 2, and x can be a plus or minus square root of 3. So whichever the examiners wanted, that's how I would have presented the answers, okay? Then 1.2, I solve for x. We have negative x squared minus 9x plus 4 is equal to 0, correct two decimal places. Remember what we say, that in a scenario like this, where they give us a condition, automatically they want us to use the quadratic formula, meaning that our a is a negative 15, our b is a negative 9, and then our c is a 4. So a quadratic formula states that negative b plus minus square root of b squared minus 4ac divided by twice a. If we substitute this, negative and negative 9 plus minus square root, we have negative 9 squared minus 4. Our a is negative 15. Our c is a 4. Everything is being divided by 2, multiplied by negative 15. Okay, so the first x value that I'm getting is going to be negative 0.897. But if we round it off to 2 decimals, it's going to be 0.90. And then the other second one is 0.297, which is 0.30. So those would be the best solutions, okay? Please, if I go astray, feel free to guide me, okay? 1.2.2, we have the quadratic inequality. Step number 1, we need to open up this bracket and create a standard equation. Okay, so that's going to be, remember, this square bracket is like 3x minus 2 multiplied by 3x minus 2 is greater or equal to 3x. Opening that, we have 9x squared minus, that's going to be a 6 times 2, which is a 12x plus 4. I move the 3 that side, minus 3x is greater or equal to 0. Let's collect the like terms. So 9x squared minus 15x plus 4 should be greater or equal to 0. Then we can get the factors or use the quadratic formula. So I have a 3x and a 3x. I'll have a 4 and a 1, and then negatives greater or equal to 0. So my critical values will be basically 1 over 3. And then I'm going to have 4 over 3. Okay, so if these are the critical values, I need to represent my solutions. Our A is positive, the sign is greater, meaning that x must be less or equal to the lower value, or x needs to be greater or equal to the bigger value. Okay, so that's how I would have represented the solutions. Alternatively, there are people that love drawing the parabolas. Okay, so this would have been a 1 over 3. This would have been a 4 over 3. And then your focus is this area. Okay, so something like that. So that is 1.2.2. Then 1.2.3, which is the exponential equation for 4 marks. Okay, this question looks a bit tricky, but my first option would be to open up this bracket so that we can see what is really happening. And one thing we know that if we have some exponential terms with a plus or minus in between, then factorization needs to be done. Let's see. If I have 5 to the x here is equal to 5 times 4 is a 20 minus, if I multiply this 5 with exponent 1 to this, I'm going to have something like 5 to the exponent of 3 minus x. Remember, from the laws of exponents, when you multiply numbers with the same basis, you must add up the exponents. So it's a 2 minus x plus a 1. Okay, we get to that. Let's collect, or let's move this negative 5 to that side. So I'll have 5 to the x plus 5 to the 3. Let me try to split this over 5 to the x is equal to 20. Because if I apply law number 2 for the division, it will subtract. Then from here, the quickest that I think I can use is let 5 to the x be a y. Okay, meaning that y plus 5 cubed is 125 divided by y gives me a 20. Multiply through by 5, sorry, by y. It's going to be y squared plus 125 is equal to 20y. Let's create a standard equation. Y squared minus 20y plus 125 gives us a 0. Okay, so if I try to factorize that out, okay, I'm going to have something like y plus a 5, and then y minus 25. Okay, so y plus 5, and then y minus 25 is equal to 0. That's a bit faint. Okay, then what we need to do next, meaning that y is negative 5 or y is a 25. So we can never have a solution whereby the exponent is giving us a negative answer. So we don't have solutions for that. But then 5x can give us 25, which is the same as 5 squared, meaning that our x is going to be a 2. That's how I would have done, or that's how I would have gone about with this question to obtain my value of x. Okay, we'll move on to 1.3, which is the simultaneous. Now, I don't know what's wrong with the examiners. No? It's like they are just proving to be complicated. They want to complicate life. So log 16 base x is equal to 4. Y is equal to this. And then they are telling us that x needs to be greater or equal to 0. So what I believe they wanted to test is basically your knowledge of converting log forms into exponential form and something of the sort. Okay, so if our x is a base, okay, even when I'm switching the 16 and the 4, meaning that if I have x to the 4, it should give me 16. Okay, then I need to find the fourth root on either sides of the equal signs. So that dies out, meaning that our x is going to be a 2. But it should be a plus or minus 2. Okay, but since they told us that x needs to be greater than 0, meaning that our x should be just a 2. Then I'm going to get this x and substitute it into this second equation and say that y plus the square root of 2 plus 7 should give us 2 plus 1. So y plus the square root of 9 should give us a 3. But we know that the square root of 9 is a positive or negative. Okay, so meaning that y plus minus 3 should give us a 3. Okay, then if I focus on the positive and I move it that side, meaning that y is going to be a 0. Or if I focus on the negative, then my y is going to be a 6. Okay, so basically that is what I'm ending up with, okay, as my solutions for that question. It's a bit tricky, okay, but that's what we would have done. 1.4, calculate two numerical values for p so that this entire expression is a perfect square. Okay, so one thing we know is that for us to get a perfect square, the discriminant should be able to give us a perfect square itself. Not necessarily, but a square number. So what we're gonna do, let's expand this and say that x squared plus 2px plus 7p plus 8. Okay, then from there, okay, so open this up. I'm going to equate this to 0. So I'm technically going to solve for p, okay, using the nature of roots. And then I'll explain further how I'm doing or why I'm doing that. So meaning that from this, we know that our a is going to be a 1. Our b is going to be a 2p. And then our c is going to be a 7p plus 8. B squared minus 4ac, I'll just equate it to 0. And then I'll have 2p squared minus 4 into 1 into 7p plus 8 should give us a 0. So this becomes a 4p squared minus, gonna be a 28p minus a 32 is 0. We can divide through by 4. P squared minus 7p minus 8 is 0. Factor this out. It's a p minus 8, a p plus 1. So either p is going to be 8 or p should be a negative 1. So that's how I would have gone about that. So for an expression to be a perfect square, in other words, it should be in form of something like x plus a, but everything squared. So if you substitute the 8 and the negative 1 back into that, I believe we should be able to express now the whole thing, the simplified version, into something whose square root we can find. Okay, so that is how the tricky question 1 would have been answered. All right, question 2, sequence and series. The following sequence of numbers forms a quadratic. Thank you. So the first difference says also form a sequence, determine the expression for the nth term. So mind you that the first difference of a quadratic will be arithmetic, okay? So if you have -3, -2, what's happening there? We are basically adding a 1, and then there we are subtracting a 1. And then we are subtracting a 3, meaning that our second difference is basically -2. -2. So we say Tn is equal to A plus n minus 1 into D. So our first term for the first difference is a 1 plus the n minus 1, multiplying it with a -2. So it's a -2n plus 2 plus 1, which is a -2n plus 3. So that's what the question wanted. Then calculate the first difference between the 35th and the 36th term of the quadratic. Now, one thing you need to know is that this 1, the first term, or term number 1 of the arithmetic, is between T1 and T2 of the quadratic. Term number 2 is between T2 and T3. Term number 3 is between T3 and T4, meaning that in this case, we need to look for T35 of the arithmetic, meaning that from where we stopped, we should look for T35, which is going to be -2 times the 35 plus a 3. So that's a -70 plus 3, which is a -67. All right, then 2.3, they want us to get the expression for the quadratic, the nth term for the quadratic. So we know that our 2a is going to be equated to this, 3a plus b is that. So let's start and say that 2a is equal to -2. Divide both sides by 2, a becomes a -1. Then 3a plus b is equal to 1, which was the first term of the arithmetic. Our a is -1, okay, plus b should give us a 1. It becomes a negative when you move it that side, meaning it's going to be 1 plus 3, which is a 4. And a plus b plus c should give us our first term of the quadratic, which was a -3. Okay, then we're going to have to do the substitutions. -1 plus a 4 plus c should give us a -3. This is going to be a 3 plus c is a -3, which means c is going to be, when we move this one to that side, it's a -6. So the Tn, remember the general term of a quadratic is an squared plus bn plus c. So meaning that we have -n squared plus 4n minus 6 as our result. All right, so that is 2.3 for the suite 4 marks. Then they're asking us why the sequence will never contain a positive term. Now, what you can notice is that it starts low, then slightly goes up to a -2, and then drops. So what this tells us is that this -2 is the maximum, okay? And besides it being a maximum, it's like this graph is a frown. Okay, it's a frowning graph because the A is already negative. So what we can say is that the maximum value, the maximum of the sequence is -2. I believe that should be able to settle it, because if the maximum is a -2, then there's no way we can have a positive number or a positive term. All right, so that is what we would have said. Then question number 3, the graphic, is it the graphic or the graph below? Okay, shows a dartboard from which patterns relevant to different circles can be derived. There are D of the largest circle, and then moving consecutively to immediate inward circles is given by 18 centimeters, 6√3, then 6, and then the innermost is 2/3 of a centimeter. Can we show that the areas of the circles form converging geometric sequence? Now, one thing we need to know is that the condition for sequences to be converging is that the common ratio must be between -1 and 1. So we know that the area of a circle is given by pi radius squared. Okay, so if I'm looking at the area of the biggest circle, it's going to be pi multiplied by 18 squared. Area of the second circle, I'll have pi multiplied by 6√3 squared. Then let me divide these two to get my common ratio. Okay, so I'm going to say the common ratio of the areas will be A2 divided by A1. So it's a pi 6√3 squared over pi into 18 squared. Okay, so when I do that magic with my calculator, I'm just getting a 1/3. Okay, so we can say that since -1 less 1/3 less 1, okay, you then draw the conclusion that the areas of the circles converge. Okay, they form a convergent geometric sequence. So that's what we needed to do. Then I know the temptation would have happened for somebody to just divide this and this to get the common ratio for the radii. That is tricky. Remember the question focused on the areas. Okay, then calculate the number of circles in the sequence that will be forming the dartboard. So for me to get the number of circles, the question is more or less asking for n. Okay, but they gave us the radius of the last circle, meaning that the radius of the is 2/3 of a centimeter. So it's up to you how you want to do it. You can either look at the area part of it, or you could just focus on the radius of each one. So since I started with the area, I just want to keep the area, okay? Meaning that the area of the last circle is going to be pi into 2/3 squared, because it's pi radius squared. This is going to give me 4/9 pi. From our general term of a geometric, we know that Tn is given as AR to the n minus 1. Where there is Tn, I'll represent the 4/9 pi. What was my first area? We said it was 18 squared. 18 squared gives me 324 pi. Okay, so that's the first area. We say the common ratio is 1/3 to the n minus 1. Okay, then what I'm going to do, I can start by cancelling out the pi's on either side. So this cancels that, and then I can divide. So 4/9 divided by 324 should give me 1/3 to the exponent of n minus 1. This gives me 1/729 is equal to 1/3 to the n minus 1. Then I know that 3 to the exponent of 6 gives me 729. So this should be 1/3 to the 6 is equal to 1/3 to the n minus 1. Drop the bases since they are all 1/3, 1/3, so that n minus 1 is a 6, and then n becomes a 7. Okay, so that is how I would have answered 3.1.2. Then 3.2, given the series, 1 times 2 plus 5 times 6 plus 9 times 10 and so on and so on and so on. They want us to write the series in sigma notation, and we don't have to calculate the value of the series. Perfect. Now, I know somebody might be tempted to multiply these brackets and try to get a sequence that is suicidal, okay? What I would request is look at the first term or the first terms of each bracket. You'll see that they are forming some sort of a pattern. So it's a 1, there's a +4, there's a +4, there's a +4, and so on and so forth. Then look at the second numbers, 2 and 6, 6 and 10, 10 and 14, which means it's also a +4, a +4, a +4. Okay, so if the two numbers are forming some sort of arithmetic, what we need to do? We need to start by finding out how many terms are there for us to get to 81, for us to get to 82. So we can use just one scenario. So if I look at the top part, I know that the Tn of the first number, Tn of the first number is going to be a 4n minus 3. Okay, remember it is a plus n minus 1 into d. Your a is a 1 plus n minus 1, your d is a 4. So it's a 4n minus 3. So if I equate my last term, which is 81, so it's 81. Does that make sense? Am I using the correct number? Yes. So 81 is equal to 4n minus 3. I move this one that side, which becomes 84. Okay. 84 is equal to 4n. Then divide both sides by 4. Then n becomes a 21. So we basically have 21 terms. Okay. Now, if that is 21 terms, I need to also get the Tn of the second number. Since it's 4n, it's going to be 4n minus 2. Okay. Because times 1 is going to be 4 minus 2 is 2 times 2 is 8 minus 2, which is 6. Okay, which is correct. So if I replace this by the 82, it's also going to give me the same thing, which means I'm looking at 21 terms. Okay, so meaning that I can come down and say that my sigma n must start from 1. Okay, because if I replace zeros here, I'm going to get negative numbers, which does not align. But if I use ones, then it will respect that. So I'm going to have 4n minus 3 into 4n minus 2. Now, since we're talking of 21 terms and we're starting from 1, meaning that the end here should be a 21, because it will be a 21 minus 1 plus 1, so that we have that 21 terms. So I think this is what the question was asking for. All right, then question 3.3, they're telling us that in the series, we have AR squared, and the sum to infinity is 1. And then in the series where the terms are squares, okay, meaning that we have a squared plus a squared r squared plus a squared r to the 4. The sum to infinity is 5/6. Determine the common ratio. 5 marks. Okay, so let's start by getting to remember that sum to infinity is given as a over 1 minus r. So with the first part, if this is equated to 1, cross multiply, meaning that a is going to be 1 minus r. Let's call that equation number 1. And then let's apply the same formula to the second series, meaning that our a squared over, okay, what's going to be the common ratio? Common ratio is going to be 1. It's going to be r squared. This must give us 5 over 6. But our a is this, because this is now equation 2. So you're going to substitute equation 1 into equation 2. Okay? Meaning that it's 1 minus r, everything is squared, over 1 minus r squared gives us a 5 over 6. Let's expand the top one, which is 1 minus r, into 1 minus r. Let's use a difference of 2 squares at the bottom, 1 minus r, then 1 plus r should give us 5 over 6. So this cancels that. Let's try to cross multiply at this point. So 6 into 1 minus r should give us 5 into 1 plus r. Okay, so let's see, opening that, we shall have a 6 minus 6r. Opening the right-hand side, we shall have a 5 plus a 5r. And then let's regroup, okay? I'm gonna move the 6 that side, I'm gonna move the 5 that side, or whichever way you wanna do it. So meaning that 6 minus 5 is a 1, and then 6 plus 5 is gonna be 11r, meaning that my r is 1 over 11. What was the question asking for? Just the common ratio. All right, so that is the common ratio that I obtained. Then question number 4, the functions. They're telling us that the graphs of the functions f of x, a over x plus p plus q, and then h mx plus c are sketched below. Okay. They want us to write down the values of P and Q. So P and Q, those are asymptotes, okay? So we can see that Y is a -1, so Q is a -1. Then they told us that P, okay, we know that this asymptote is a -2, then P must be just a +2. Okay, then calculate the value of A, but why just 1 mark? Doesn't make sense, but it's fine. Let's give it a try. So f of x is equal to a over x plus 2 minus 1. So we're going to use the coordinate that we know, the -4 and then the 5 over 2, because it can't be just 1 mark for, you know, there's a lot that needs to be done. Okay, so it's -5 over 2 is equal to a over -4 plus 2 minus 1. Okay, so -5 over 2, I can move this one to that side so that I have a +1 is equal to a over -2. So negative that and that, why don't I just multiply both sides by -2 at once? I mean, even the mark allocation just demotivates someone from, you know. So the a value that I'm getting is a3. Okay, probably I'm using a longer approach. People could help with simpler approaches for this 1 mark, because it's not fair. Okay, 4.3, they want us to get the range. So for the range, we are basically being asked for the y values for these graphs, especially the hyperbola one. So you can see that it can extend to the positive infinity, can go to the negative infinity of the y values. So you can say that y is an element of real numbers. Y should never be -1. Okay, that's 4.3, 4.4. They want the equation of the line of symmetry with a negative gradient. So we know with the negative gradient is -x plus c. Then we know that the points that we are supposed to use are basically the asymptotes, which asymptotes are basically -2 and -1. So let's use that -2, -1. So where there is y, we have a -1. So a negative with a -2 plus c. -1 is equal to 2 plus c. Move it that side. C becomes a -3. So the equation is -x minus 3. Okay, then write down the equations of the asymptotes of f, where x is a 4 x plus 4.5. So meaning that this graph is being shifted 4.5 units, okay, to the left. Remember, the initial asymptote was -2 and -1. So if we are moving the graph horizontally, it's only this asymptote that's going to be affected. Okay, so how is it going to look like? So it's going to be, let's say 2 plus this 4.5, which gives us 6.5, which is the same as 13/2. Okay, meaning that the asymptote is going to be x is equal to -13/2, and then y is -1. Or you can say x is equal to -6.5, and then y stays the same because the shifting or the transformation is only happening within the horizontal. All right, so that is what was expected of us for 4.5, and then as well as question 4. And then question 5, okay, given the f of x is a parabola, g of x, straight line, h of x, a log function. Write down the coordinates of the turning point of f. So turning point, we can start by finding the axis of symmetry, okay? X is -b/2a. So from here, we know that our a is a 2, our b is a -1. So it's a negative with a -1 over twice times 2, which gives us a quarter, okay? But they want the coordinates, so we need to find the y values also. So f of a quarter is going to be 2 times a quarter squared minus a quarter minus 15. Okay, so when I punch that into the calculator, I'm getting -121/8, meaning that those coordinates will be 1/4, then -121/8. But why must examiners be stingy with marks? Because just 2 marks, like really? Okay, show that the x-coordinates of the x-intercepts of f are this and that. Okay, so they want us to factorize and show them how we are factorizing. So y is going to be a 0 for the x-intercept. Okay, open your brackets. So 2x squared is just going to be 2x and x. For me to get a 15, I can have the 5 and the 3. So where am I putting the 5? I can put it here. Can put my 3 there. Is it going to make sense? Okay, I can put a negative, can put a positive, because that's going to be a 6 and then a 5, which gives me a negative. Perfect. So meaning that x is going to be -5/2, or x is going to be a 3. That's all they needed. Sure. For 1 mark. All right. Then they want us to do the sketch. Okay. So with the sketch, we're being advised that we must practice sketching graphs using pens. Okay. I'm not going to say anything negative about it, but we just need to be careful. Okay. Let's say we can start with a pencil. When you feel like the graph is now perfect, then you can go ahead and trace it back with a pen. Okay, so with f, we know that the points of intersection, we said -2,5 and then a 3. Let's start with that. So if this is a 3, 2,5 should be somewhere there. It's a -5/2. Do we know the y-intercept? We say the y-intercept is -15. -15. Because the turning point was 1/4. So slightly somewhere there. Okay, so sketch that. Okay, so let's just have that as our f. Remember, it's a sketch. What we need will be the intercepts. Okay, this is our turning point, perfect. And then 2, we need g. Remember, g was a 3x minus 9/2. So if I'm to translate or interpret this, I need to look for the x-intercept and y-intercept. So this is the y-intercept, which is 4,5 negative, which is somewhere there. I can say it's a negative 9/2. Okay, then if y is a 0, I have a 9/2 is equal to 3x, meaning that 9/6 should be the x, which is a 3/2, which is like 1,5 somewhere here. It's a 3/2, 1,5. So get the x-intercept, get the y-intercept. Remember, this one is a straight line. Okay, so it should just continue. This is G. And then H, which is the log equation, we have the log of 1/3x. Okay, can play around with it. What I'm seeing is that if I'm to plot this graph properly, when I'm not going to say that it's 1,5, which means 1 should be somewhere here at a point of 1. So this graph must just move towards the y-axis and in this sort of direction. So that is your H. All right, so that is what we have for that particular question. Then they are telling us that if H is a point on G, R is a point on F, such that, yes, this word, guys. So something is not right. I mean, the examiner cannot be examining English instead of maths, because this word is complex. But in other words, it represents the x-axis, such that x-axis or the x-coordinate, something like that. So the x-coordinate of both points is 4. So I determine the length of HR. So H is on G. H is on G. R is on F. Then they want us to get this distance. If this is a 4, so we need to get the difference there. So step number 1, since we're looking for the distance between the graph that's above is F. So I'll say F minus G. Okay, so it's the F of X minus the G of X. Remember, our F of X is basically 2x squared minus x minus 15 minus this is 3x minus 9/2. Can open up, simplify, and maybe substitute. If x is a 4, just replace x with a 4. So 4 squared minus 4 minus 15 minus 3 times 4 plus 9/2, because I'm opening a negative and negative. Okay, when I punch that, I'm getting 5,5, or basically 11/2 units. Okay, that's one way to do it. The other alternative that I feel would have been quick is for you to get f of 4. Okay, and then you're going to get something like a 13. And then you look for g of 4. This gives you something like a 50 greater than. Wait a minute. Am I doing the right thing? We're saying, remember, this is now the inverse. Okay. Yeah, I think it makes sense. Y is greater than 0, x is an element of real numbers. Then 5.6 determine the value of values of k if the roots are equal. So when roots are equal, it means the discriminant is equal to 0. So our a is a 2, our b is -1, our c is a k. So b squared minus 4ac is equal to 0. -1 squared minus 4 into 2 times k is a 0. So 1 minus 8k should be 0. Move the 8k that side or move the 1. So -8k is -1. Divide both sides by 8. K becomes 1/8. All right, so that is 5.6. 5.7, they want us to get the maximum, g of x minus f of x. Okay, so we know that the g of x was, what was the g? It was the 3x minus 9, 9 over 2. Okay. Minus our f of x is 2x squared minus x minus 15. This is the expression. Okay. Then let's open it up. But they want the maximum value. Okay, we can use calculus somewhere, somehow, and then we differentiate. So 2x squared is going to be plus x plus 15. Derivative of 3x is 3. This is going to be a 0 minus, this is going to be 4x plus 1. This dies out, meaning that it's negative 4x plus 4 is equal to 0. So x is going to be a 1. Okay, so meaning that the maximum happens when x is a 1. Then let me just substitute this one back into that expression and see what I end up with. So it's going to be 3 times 1 minus 9 over 2 minus, we have, but why should I use a bracket when I opened? All right, so we're saying 2 times 1 squared plus 1 plus a 15. Okay, so I'm getting something like 12,5. That's the maximum. Okay, the maximum is 12,5. All right, so that is what I would have obtained for that particular question. Question 6, we have f of x is 3 to the x. They want us to get the inverse, okay, in this form. So the inverse is basically the log x base 3. Then they want us to sketch both graphs, the f and its inverse. Okay, let's see. If this is your y, this is your x. So we have 3 to the x as our f. So if x is 0, we know that it will be at a 1. And then if x is a 1, then it's going to be at a 3. So meaning that our graph should be just in that sort of direction. Okay, so that is f. And then the inverse, just switch points, 0, 1, 1, 0. 1, 3, it's going to be a 3 and a 1. Okay, 3 and a 1, somewhere there. So meaning that this graph should just move in this sort of direction. Okay, so that is what we have. We are saying this is the inverse. Okay, then write down the equation of the line of symmetry between the two graphs. So the line, remember, an inverse function is basically a graph that is being reflected about the line y is equal to x. Then for which values will this f and its inverse be less or equal to? In other words, when we get a negative result, or a result that is equal to 0. So f is above, meaning that it's just positive. So we need to look for a scenario where f is positive and g is below. No, f inverse. So the only section that we are seeing is this section. Okay, if I'm to draw my line, it's just this section here. One is below, the other one is above. So between 0 and 1. So my solution in that case would have been 0 less x less or equal to 1. I don't want to put the equal sign because 0 is an asymptote to the other graph. All right, then write the range of this function. Okay, so it's a 3 to the negative x, then we minus 4. What is happening? So the original graph of f, it's being reflected about the y-axis, okay? And then remember, if you reflect it about the y-axis, you're gonna get a shape of something like this. Okay, but then they are moving it 4 units down. Okay, so this point here will be at a -3 somewhere. And I want to believe that -4 is going to be our asymptote. So what we're going to say is that y should be greater than -4. All right, then write down an equation for g if g is the image of f after it has been translated 2 units to the right and reflected above the x-axis. So our f of x was just 3 to the x. Now I want to translate it 2 units to the right. It's going to become 3 to the x. No, not plus. When you are moving to the right, it has to be a minus, okay? Then when you reflect above the x-axis, this entire thing becomes negative, meaning that our graph of g is going to be -3 to the x minus 2. All right, so that is how question 6 would have been answered. Question number 7, finance. All right, a business buys a machine that costs 120,000. The value of the machine depreciates at 9% per annum according to the diminishing. Sometimes we call it the reducing balance method. So reducing balance is 1 minus I to the exponent of n. So 120,000 is the initial value, or the P, into 1 minus 9% is going to be 0.09 to the exponent of 5. So P is 120. Our n is 5, and then our I is 0.09 per annum. All right, when I punch this into my calculator, I'm getting 74, okay, 883.86 rands. Okay, so that is what I'm getting, unless if somebody has a different answer. Probably my calculator is playing snacks with me. You're saying 1 minus? All right, so that is that. Then 7.1.2. After 5 years, the machine is to be replaced. And during that time, inflation remained the same at 7%, determining the cost of the new machine. So what we're seeing is that a machine was bought, okay? But then there are other machines that probably stayed in the shop, whose price must increase, okay? So looking at the initial price of the 120, we're going to use it to grow this amount. So we're going to use the growth formula, okay? So that's going to be 120,000 into 1 plus 0.07 to the exponent of 5. Okay, so my calculator again tells me it's 168,306.21 rands. All right, so that is what I'm getting for 7.1.2. Then 7.1.3, the business estimates that it will need approximately 90,000. Okay. So a sinking fund of this much into equal monthly installments must be paid is set up. Interest on this fund is 8.5 per annum compounded monthly. The first payment will be made immediately, and the last payment will be made at the end of the 5-year period. Calculate the value of the monthly payments into the sinking fund. So one thing we're looking at is the question is, when you're dealing with sinking fund, is it a present or a future? It's basically a future value, okay? Yes, it's a future value because it's a saving. So our future value is 90,000. Then we know that X is what we're looking for. The N is going to be, now before we get to the N, let me write the I. It's compounded monthly, 8.5% over 12. Now problem is, what's going to happen with the N? Okay, now with the n, I'm going to take my n to be a 61. Why? Because they are telling us that monthly payments must be paid, must be paid. And then the first payment will be made immediately, okay? And then the last payment will be made at the end of the 5-year period. So if this person was making, let's say, payments at the start of each month, remember this last payment comes in at the end of the period. If it was making, let's say, the payments at the end of the month, so it's like in the first month, this person makes, or this company or business makes 2 payments in 1 month. That is my interpretation of this. I will need to be deliberated or be told otherwise. Okay, so if we substitute into the formula, we have 1 plus I to the exponent of n minus 1 over I. We're looking for x, meaning that it's going to be f times I over this entire bracket, 1 plus I to the exponent of n minus 1. Let's do the substitution. So it's a 90,000 multiplied by 8.5% over 12 over 1 plus 8.5 to the exponent of 61 minus 1. So I'm getting 1184.68 rands. All right, so that is how I would have gone about with that 7.1.3. Then 7.2, this person receives an amount of 900,000 upon her retirement. Then she invests this amount immediately at a rate of 10.5% per annum compounded monthly. She needs an amount of 18,000 per month to maintain her current lifestyle and plans to withdraw the first amount at the end of the month. Perfect. How many months will she be able to sustain herself? So this is a present value situation, okay, whereby we're looking for, let's first put this down, negative n over I. We're looking for the n after how many months. So our P is the 900,000, and then the X is the 18,000 into 1 minus 1 plus the I, which is a 0.105 over 12 to the exponent of negative n. We're dividing this by 0.105 over 12. All right, so first things first, I can divide both sides by the 18,000 and then multiply with this. So I'm saying 900,000 over the 18,000 times 0.105 over 2. Okay, wherever I get here, I must subtract 1, and then I'll get a negative answer. Okay, so if I simplify my bracket with the n, I'm getting, I'm getting a 1,00875, the exponent of negative n. When I simplify my left-hand side, we said 900,000. Oops, we are dividing by 18,000. Okay, then we multiply by the 0.105 over 12. It's giving me, or we are subtracting a 1 after that. All right, I'm getting negative 0.95625. Okay, negative and negative is going to be a positive, okay, to the exponent of negative n. Then for me to get my negative n, I'll have the log of 1,00875. You can say over the log of 0.95625. So you're going to get a negative answer. And then my positive answer that I'm getting is a 66.043. Now we are seeing that we're going to get 66 full months of the 18,000. Okay. And then there's probably a month, or the 67th month is gonna cost less than the 18,000. So we can say 67 months because that's when all the money will be finished. All right, then 8.1, calculus. First principles, we know that the formula is the limit as h tends to 0, f of x plus h minus the f of x over h. Okay, so if that's our f of x, then our f of x plus h is going to be negative 2 into x plus h squared minus 1. So limit as h tends to 0, it's going to be negative 2 into x plus h squared minus our f of x, which is negative 2x squared plus 1 divided by h. Limit as h tends to 0, negative 2, we open this up, we're going to have x squared, 2xh, and h squared. Minus, no, that's going to be a plus now, 2x squared minus 1. This is all over h. So limit as h tends to 0, let's open this up. We have negative 2x squared minus 4xh minus 2h squared plus 2x squared minus 1. Did I leave out something? Looks like I left out something. Because this is supposed to be a 1 somewhere here, meaning that there's a plus 1 that I left out. Okay, so if that 1 is there, remember we are dividing by h because the f of x needs to cancel out everything. So this cancels this cancels that. Okay, then my next step is to factor out, okay, the h. I'll have negative 4x minus 2h over h. So this cancels that. And then I substitute h with 0, which means it's negative 4x. But why are they giving 4 marks from the usual 5? Hence, calculate the gradient of the tangent of f at this point. So we know that the first derivative is like a gradient function, okay? Meaning that f prime of negative a half is going to be negative 4 multiplied by negative a half. And this gives us a positive 2. Okay, so that becomes a positive 2, and then that is our gradient. All right, then 8.2, determine the derivative of this. Okay, so let's change the root signs and let's move this from the bottom, we take it to the top. So that's going to be x to the 2 over 3, because the cube root is like exponent, a third. Okay, then you multiply with the 2, you get 2 over 3. Plus, I'm going to have 1 over 4. I have to take this up, comes x to the negative 4. All right, then from there, I can now do the derivative. So it's going to be 2 over 3x. I subtract a 1. I get negative 1 over 3. Then this multiplied by this, I'm going to have a negative. The 4 is going to cancel with the 4. Then x to the negative 5. So for as long as the question does not ask me to give the answer with positive exponents, I'll just leave it at that. Okay, 8.3. Given h of x is x squared, whereby a must be greater than 0, determine the value of a if it's given that the h negative 1, okay, which is the inverse, né? And then h prime is the derivative, okay, that the two are going to be the same. Remember here, it told us f prime, which is the derivative. Okay, so one thing we need to know is that let's start with the derivative because it's a bit quicker. So h prime of x is going to be 2ax. But then they're telling us if x is a 4, okay, h prime of 4 is going to be 2 times a times 4, which gives us 8a. Call that equation 1. Then let's get the inverse. So inverse will be like y is ax squared. Switch them. X is ay squared. divide both sides by a, and then find the square root. So y is a plus minus. Okay, but they told us that a must be greater than 0. We shall see. Okay, so if now I replace, because now this is my inverse, h negative 1 of x, meaning that if I look at the negative 1 of 8, it's going to be like the square root of 8 over a, okay, plus minus. Then I need to equate the two. So meaning, if this is my equation number 2, so equation 1 equated to equation 2, we're going to have 8a is equal to the square root of 8 over a. Get rid of the square root, you square both sides. We square both sides, so this 2 kills the root. We're going to have 64a squared. Okay, so that's a 64a squared is equal to 8 over a. Cross multiply, no problem. So you're going to have 64a cubed is equal to 8. Okay, and then from there, we can feel free to divide both sides by 64. So over 64 over 64. So this cancels that. A cubed becomes 1 over 8, and then find the cube root. Okay, so meaning that a is a 1 over 2. All right, so that is how I would have obtained those 5 marks for myself. All right, then question number 9, where I believe the examiners were kind of unfair with the mark allocation. Anyway, let me not complain about marks, but I'm being realistic. So the graph of the function, okay, is sketched below. Point A is a stationary point, perfect. Point B is 4, 0, which is an x-intercept. Point P is the point of inflection, point C is a turning point, and then point D is the y-intercept, which is okay. Now, 9.1, like how do we have to find A, B, and C for only 3 marks? Let's see. Because I see there's a lot that needs to be done here. So step number 1, let's try to use this. Okay, along the x-intercept, y is going to be a 0. We can just replace x with 1 and then see what's going to happen. So meaning that 0 is equal to, this is going to be a negative 2 plus a plus b plus c. When I create an equation from there, a plus b plus c gives me a 2. That's equation 1. Let me use this other x-intercept, 4 and 0, meaning that if we have 4 cubed, it's going to be 64 times 2, which is 128. So negative 128 is equal to, we have 4 squared, that's going to be a 16. Why am I putting a plus sign? Okay, so we're saying that's going to be a 16a minus, is it minus or plus? It's a plus. The b is going to be 4b plus c is a 0. Rearrange this, you have 16a plus 4b plus c gives us 128. That is equation number 2. Okay, then I need to subtract these 2 equations. Okay, so I'm saying I need to subtract the 2 equations. So I'll say equation 2 minus equation 1. So 16 minus a, I'll get 15a. 4b minus b, I'll get a 3b. C minus c is a 0. 128 minus that, I get a 126. I'll call this equation number 3. Then we were given a turning point. Okay, this 1 and 0. Oh, I see why it is a 3-mark question. It now makes sense. Okay, because like the approach I'm using is a long approach. It's a long approach, but it's fine. Let me just finish it since I'm already halfway through it. Because one thing that I've noticed that this is a turning point and an intercept, meaning that's supposed to be something like x minus something squared plus blah, 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 but it's fine. What did we do wrong? So, okay, let me just finish with this. Then I'll show you that other approach because it was gonna, yeah, maybe that's how the 3 marks would come about. Okay, so let me find the derivative of that, which is gonna be negative 6x squared plus 2ax plus a b. Then replace x with 1, meaning that's a negative 6 plus 2a plus b is a 0. So in other words, we have 2a plus b is equal to 6. Okay. And so if we have something like that, does it make sense? No, it doesn't. It's not making sense. Okay, so what would we say? If x is a 1, that's a negative 6 plus 2a. And then we are saying plus b should give us a 0, 2a and that is a 0. Okay, so where is that other point that we need? Because we've substituted almost everything. So the other point that I'm seeing is 2a plus b is equal to 6. I can make b the subject, or I can just solve these two simultaneously. So if I multiply by 3 here, by 3, and then by 3. So 15 minus 6 is going to give me 9a. This will cancel out. I know that 6 times 3 is 18, so 126 minus 18 gives me 108. So over 9 and over 9, and then our a becomes 12. Okay, which is what we have. Then replace a with 12 and let's find b. So 2 times 12 plus b is a 6. So b is 6 minus 24, which is a negative 18. Okay. And then lastly, we substitute into the first equation, a plus b plus c is a 2. Okay. We're saying a plus b plus c gives us a 2. So 12 minus 18 plus c is equal to 2, and then c is going to be 8. So what I was saying is that the other alternative is by looking at the point A and B, since they are intercepts. So meaning that if we have A, why am I saying A? Let me just use negative 2, since the first term is a negative 2. X minus 1 squared into x minus 4. If we open this up, okay, because this is a turning point and an intercept, that's why we are squaring it. This is another point. We are saying our a is a negative 2 because it is represented there. So if I open this up, let's see if we get the same thing very fast. So negative 2, we have x squared minus 2x plus 1, x minus 4. Okay, so negative 2 stays there. That's going to be x cubed minus 2x squared plus x minus, this is going to be 4x squared minus 8x minus 4. When I open up this, is going to be a negative 2x cubed. This and this is going to be negative 6. Negative 6 times negative 2, I get a positive 12x squared. And then this and this gives me, did I do something wrong? Did I leave out a 2 somewhere? Because this x squared, x cubed minus 2x squared plus x. Okay, because I'm getting a negative 7 and then that's a negative 14, which doesn't make sense for me. And then the negative and negative, we are getting a positive 8. So the 12 is out, the 8 is out, then this should be a negative. So that we have a negative 9. So, but this approach, I believe, is what was meant for the 3 marks and not the original one. So Whichever way you go, you should be able to get your full marks. So this should be actually positive, so that positive and positive, we get a negative, that gives us the 9, which is a positive 18. Yeah, makes sense. Okay, so that's what the exam is. So it's like they never even gave options. You see, that's the problem of this answer book, whereby the spaces are given, they don't accommodate all the options that are possible. Nevertheless, that's what was supposed to be done. Next, they're telling us that this person states that the tangent to the curve of f can be drawn through points C and D. Validate the statement using the appropriate calculation. So a tangent to be drawn through points C and D. Where is C? This is C. Where is D? This is D. So if a tangent is to pass through C and D, yes, we don't deny it could be a tangent, but it is touching 2 points of the graph. Okay. And if that is the case, will that still be a tangent? Unless if it's just at 1 point. Okay. So the question is asking us to validate the statement. They are not asking us for the equation or what states that a tangent can be drawn. The answer is a no. A tangent must always pass through 1 point on the graph. Okay, so that is that 9.3 A, P, B are joined from this triangle. And then they want us to get the area of A, P, B. Okay, so if I'm to draw that triangle, saying A, P, and B. So meaning that I need to get my base, which is gonna be like 3 units, because 1 and 4 is 3 units. Only thing I need to get is this height, which height will be obtained from the point of inflection. So let's get the first derivative and the second derivative. So my first derivative is going to be negative 6x squared plus 24x minus 18. Is it minus 18 or plus 18? Because we said b is a minus 18. Okay, it's a minus 18. So if that's the case, then our second derivative is going to be negative 12x plus a 24. Equate that to 0, meaning that x is going to be a positive 2. When I substitute this into the original, okay, I'm going to get something like a 4, meaning that my point P is at 2 and 4. And if it is at 2 and 4, the height here becomes 4. Okay, that height is 4. So the base is 3, the height is 4, meaning that the area of that triangle will be a half times 3 times 4, which is 6 units squared. All right, then for what values of x is f concave down? So we know that the second derivative should be less than 0. Okay, and remember what we said with the second derivative, it's negative 12x plus 24 is less than 0. Negative 12x is negative 24, meaning that x needs to be greater than 2. Okay, then write down the values of x for which the graph is strictly increasing. So if this is a 2, okay, that is a 2, this is a 1, okay, the distance there is 1 unit, so this turning point here must be at a 3. Okay, so this area, that's where we are finding the graph to be strictly increasing. So our values of x will be 1, okay, less x, less 3. Then write down the coordinates of the turning point of h of x, which is the same as f of x minus 3. So with the turning point, what I need to know is that if my x here is a 3, what's going to be my y value? So I just need to, again, substitute f of 3, okay? And then my y value in that case is going to be something weird, which is 8. Okay, so 3 and 8 will become my values for this turning point. 1 and 0 will be that. But from the equation, we can see that f of x minus 3. So it's like we are shifting this graph 3 units down, meaning the x is going to be maintained. We're going to have a negative 3. X is going to be maintained. We're going to have a 5 because 8 minus 3 is a 5. So the answers for the last question, 9.6, should be 1 and negative 3. And then we can have 3 and 5. Okay. Then question 10, a metal box without a top is to be constructed. And we saw this question during our preparation from that paper we saw. So a rectangular metal box. Okay. So no, it's not rectangular, it's a square. So this is 20, that is 20. Then we have to cut out corners that are of equal measurements. So if that is x, that is x, 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 and everywhere it's x, meaning that the distance that we're going to be left with here is going to be a 20 minus 2x. So even this side is going to be a 20 minus 2x. But then when you're doing the folding, this x becomes the height. So our height is x. Our breadth is 20 minus 2x. Our length is a 20 minus 2x. Remember, it's a square, so it's going to be the same distance. Then volume, okay, because the question is asking for the dimensions that will give us the biggest volume. So let's get the volume. So it's going to be 20 minus 2x, 20 minus 2x multiplied by x. Opening this, it's going to be 400 minus 40x minus 40x plus 4x squared. Okay, so that becomes 400x. That's going to be 80x squared, and then plus 4x cubed. So this is our volume. And then for maximum volume, we must optimize this, meaning that we have a 400 minus 160x plus 12x squared. We can equate this to 0 and solve this quadratic. Okay, so when I solve this, I'm having something like x minus 10 and then 3x, because I divide through by 4. Okay, when I divide through by 4, okay, minus 10 is equal to 0. Then my x is a 10, or my x is 10 over 3. But now what you need to know is that we need to select one value. An example, if you look at 10, 10 is not reasonable, it's not applicable, it's not logical enough, because the entire distance is a 20, okay? And then if that's a 10 and that's a 10 already, it's finished without even considering that. So 10 cannot be used, it cannot be a solution. So this becomes the solution. What was the question asking for? Calculate the dimensions. All right, so we have our h as 10 over 3. We need to get the length, which is 20 minus 2 times 10 over 3, which gives us a 40 over 3. So the length, which is equal to the breadth, 40 over 3, the height is 10 over 3. So those are the dimensions that the question was looking for. All right, question 11, we have event A, a 6-sided die being rolled. Okay, so how many events? 1, 2, 3, 4, 5, 6. The number observed is 2 at most, meaning maximum is 2. So meaning that we can have 1, we can have 2. Number that landed up is an even number, so it's 2, 4, 6. And then the number up is a 6. Bit of B times the probability of C. So how many events are there between B and C? Okay, we're seeing just the 6, which is one event or one element. So we're going to say it's 1 over 6. Probability of B, how many elements do we have in B? We have round about 2 elements. No, it's not 2 elements in B. Let's go back and see. In B, we have 3, meaning that's going to be a 3/6 times number that landed up is an even number. So it's 2, 4, 6. And then the number up is a 6. Determine separately the probability of getting A. So A is having 2 events. So it's 2/6, which is 1/3. Probability of B, we have only 3 events. So 3/6, which is 1/2. That's how we answer that. Then use probability of A to determine the complement. So we know that the complement is the same as 1 minus initial probability. So we can get 1 minus 1/3, which must give us a 2/3. Then are the events mutually exclusive? Okay, so when you look at A and B, I know that mutually exclusive events are basically events that have nothing in common. But for this, we have 2 that is common. So the answer is going to be no. Probability of A and B is not 0. Okay, then calculate the probability of A or C. So probability of A or C using the addition rule is going to be probability of A plus probability of C minus the probability of A and C. Okay, so what is the probability of A? We got 1/3. Okay. What is the probability of C? C has just one event, which is 1/6. Okay. Minus between A and C. Okay, this is A, this is C. There's nothing common, which means it's just a -0. Simplify this. 1/3 plus 1/6 gives us 3/. Is that correct? Because it's times 2, which is like a 3/6, which is a half. Perfect. Okay, then are the events B and C independent? So for independent events, we know that the probability of B and C should be the same as the probability of B times the probability of C. So how many events are there between B and C? Okay, we're seeing just the 6, which is one event or one element. So we're gonna say it's 1/6. Probability of B, how many elements do we have in B? We have round about 2 elements. No, it's not 2 elements in B. Let's go back and see. In B, we have 3, meaning that's gonna be a 3/6 times C, we saw 1/6. Does that make sense? Yes. So by 3/1 by 3/2. So 1/6 is not the same as 1/12. Therefore, events are not independent. All right, then 11.2. Probability of getting the first answer in a quiz is 0.6. If the first answer is correct, probability of getting the next is 0.7. However, if the first answer is incorrect, probability of getting the next is this. With the use of a tree diagram, determine the probability of getting. Okay, so let's see. First answer correct, wrong. So this is going to be 0.6. This should be a 0.4. If the first answer is correct, probability of getting the next answer correct is 0.7. This is going to be a 0.3. Okay, correct, and then wrong. So then they're telling us, however, if the first answer is incorrect, probability of getting the next answer correct is 0.4. This is going to be a 0.6. So these are our outcomes. Okay, and that is the tree diagram. Now they want us to get the probability of getting the second answer correct, meaning that we can either go the route of CC or WC. So probability of CC, probability of WC. Okay, so with the CC is going to be 0.6 times 0.7. WC is going to be 0.4 times 0.4. So just punch everything into the calculator, and then we end up with our answer. So this is a 0.42 plus a 0.16. Is that correct? 0.6 times 0.7, 0.4, and that. So when I plus that, I'm getting 0.58. I hope that is what people got. Okay. Then 11.3, they're telling us that a discus cage on an athletics field must be moved to different positions. 5 boys must form a group from 15 boys to perform this task. How many different groups do we need? So we have 15 people to choose from. Okay, so it's going to be 15 divided by, because this is like a combination kind of scenario. So you're going to have 5 factorial and then 15 minus 5, which is a 10 factorial. When you punch this into the calculator, I'm getting 3003. So those are the different groups that we can obtain from all of this. All right, so guys, that brings us to the end of this paper. Okay, like as always, we appreciate your constructive criticism and we appreciate your comments, okay? This is what I would have done if I was seated in that paper. Nevertheless, the official memorandum will be out in a few days, but this is what I would have done. Nevertheless, I wish you all the best in your paper too. Let's meet then. Bye-bye. Hello and welcome to